Hello friends, once again we begin with the syllabus of electronics in which we discuss the electronics paper 1 and chapter number 2, that is of power supplies. Okay, so check carefully what we have learned in the previous lecture. So let us have the revision and then we go to the next topic from chapter of the power supply. Okay, check the presentation. Okay, so in the previous lecture, we begin with the transistorized, or we discuss the concept of transistorized regulator. So already we have learned the working of the circuit. Now what remains is the some formula from the diagram. So check carefully, we have two transistor Q1 and Q2. So based on that, we have the working of the transistorized regulator, how the regulator work, how the output voltage remain constant. So that we already learned. Now what we have the some formula, that is in case of output voltage. So check carefully, the output voltage is applied to voltage divider to produce a feedback Vf, which is applied to base of Q1. Okay. So output voltage is applied to voltage divider. Now check carefully once again, we have the diagram. So check carefully. This is output voltage and this is voltage divider network R1 and R2. Voltage divider is to R1 and here we have R2. And from this we feed the feedback voltage Vf to the base of Q1 here. Okay. And that will be has the factor or fraction. So the feedback fraction, we can have the formula beta is equal to R2 upon R1 plus R2. So that is potential across the R1. Potential across R1, that is equal to, we have the potential divider formula from 11th standard. And according to that formula, we have the fraction. So fraction of voltage across R1. So check carefully, fraction of voltage across R1, that is called beta. And that is called feedback fraction here. R2 upon R1 plus R2 here. So this is formula for feedback fraction. That fraction is nothing but the fraction of voltage appear across R1. Okay, so that is, check once again the diagram. Here we have how much voltage, that voltage or fraction of voltage across R1, and for that for voltage we have the formula beta is equal to R2 upon R1 plus R2. The closed loop gain, that is equal to ACL. So we have one formula for closed loop gain, and that will be equal to R1 1 upon beta. So closed loop gain, that is the reciprocal of fraction here, or the feedback fraction, and that will be 1 upon beta, and beta we have the formula R2 upon R1 plus R2. If you replace here beta, then we have the R2 in divide, and in multiplication we have R1 plus R2, and R1 plus R2 divided by R2. If you have R2 common, or we divide R2 to two terms, then we obtain R1 upon R2 minus 1. So after the simplifying this formula, reciprocal of this R1 upon R2 divided by R2, if we simplify, then we obtain R1 upon R2 minus 1, and that is nothing but the gain in closed loop. Okay, so this formula for gain. Now we have one more formula, the voltage, that is feedback voltage Vf is equal to Vz plus Vbe. Now check carefully, for that also we have to check the diagram. Vz is equal, Vf is equal to, check carefully, Vf is equal to, also Vf is equal to, here we have the base emitter voltage of transistor and plus Zener voltage, that is Vz. So voltage across transistor plus voltage across Zener voltage, that is equal to the Vf here from the diagram. So we have the second formula for feedback, that is called Vf is equal to Vz plus Vbe, and that is equal to, here is beta times output voltage here. Now check carefully, beta times V out, that is again we have the formula. So check carefully, Vf also equal to the voltage across the R1, and that is equal to the R1 upon R2 upon R1 plus R2 here. So accordingly we have that voltage formula. So beta means R2 upon R1 plus R2, that potential across R2, sorry, and that will be equal to here times V out. So from V out, how much fraction we have taken? The beta times fraction we have taken, and beta times V out. So this will be the feedback voltage. Okay. Now we have V out is equal to Vz plus VBE. So we write equation for V out. So beta will be taken in left hand side, divide. So Vz plus VBE divided by beta, and this is formula for V out here. Now again we have, since ACL is equal to 1 upon beta, then we have ACL is equal to 1 upon beta, then 1 upon beta we replace in V out formula as ACL. So V out is equal to ACL closed loop gain into Vz plus VBE. So this is the formula for output voltage, the closed loop gain into Vz plus VBE, where V out is equal to regulated output voltage, then ACL is equal to closed loop voltage gain, then Vz is equal to, here is the Zener voltage, VB is equal to base emitter voltage of Q1 here. Okay, so we have two formula for the feedback. So feedback factor beta is equal, fraction is beta is equal to R2 upon R1 plus R2, that is potential across this will be total, here R1 some portion and we have R2 this portion, and that is nothing but the Vf. So Vf has formula R2 upon R1 plus R2, and that also equal to the VBE plus Vz here. So there are two formula, and accordingly we have the simple equations here that we have to use for certain calculations of the problem here. Okay. Now we have one more, the regulator, and in that we have to limit the current, or that is called current limiting in series regulator. So here we have add one more, the transistor. So here in all the transistor Q1, Q2 and Q3, and that combination gives the current limiting in series regulator. Okay. So check carefully what we have, the working of this circuit. So check carefully, positive terminal and negative. We have input voltage from unregulated power supply. Then we have R5, that is given connected to the Zener diode or N type of Zener diode. Then R3 connected to the base of Q2 as well as the collector of Q1. Then from here we have series pass transistor, that is Q2. So this will be series pass element. So certain potential will be developed across the series pass element, and that will be controlled by base current here. So this is Q2 as series pass transistor, and here we have the new transistor Q1 as an extra transistor compared to the transistor as regulator. So that Q1 we have the one connection in R3, then second connection is the base and emitter we connect in between them is the 1 ohm, the resistor R4 here. So we have connect the resistance in between the base and emitter of the Q1, and that base resistance and that transistor Q1 control the current here. So role of the controlling the current is by the transistor Q1 here. Other setting will be same, base of Q3 connected to the here R1 R2 combination, again potential divider, load resistance and output voltage V out here. Okay. So what is the important part in the circuit, or the extra part in the circuit compared to the previous circuit here is, check carefully, in transistorized regulator we have only two transistor Q2 and Q1 suppose, and the Q2 has certain base, and according to base voltage the Q2 conduct the current here. If base is small, then it will doesn't conduct, it has a large resistance, and accordingly certain power will dissipates in the transistorized regulator. And also it doesn't limit the current. So this is drawback of the transistorized circuit here. But if we add one more transistor, then it will have the limiting current limiting facility as well as the short circuit protection for the regulator here. If you short the output terminals, then also the current will be limited, or the circuit doesn't get damaged here because of the extra the transistor Q1. Okay, so what is working here? Check carefully the working here. One by one we understood the concept. So what is given in number first is, if the load terminals are accidentally shorted, if load terminals means output terminals are shorted, very large load current flow which can destroy the series pass transistor or diode in unregulated power supply. So if large current will be flow when we short the supply, output of the power supply, then large current flow, and that can damage the series transistor as well as the diodes of unregulated power supply, either full wave rectifier or bridge rectifier. The diodes may get damaged here because of excess current. Now we have number second point. R4 is current sensing resistor. Now check carefully. R4 is current sensing resistor for load current less than 600 milliampere. Voltage drop across R4 is less than zero point 0.6 volt. Okay, so check carefully. R4 is act as a current sensing resistor. It is suppose 1 ohm, and if it has suppose the 600 milliampere current flow through it, then it will have the potential across it is suppose 0.6 volt. And for this condition, the base and emitter that will be having the potential less than zero point 0.6 volt, and in that case Q1 will be remain off here. Check carefully. We once again read the second number. If here R4 is current sensing resistor for load current less than 600 milliampere. If current is less than 600 milliampere, then we have the formula for voltage. V is equal to I into R. So I is 600 milliampere. So ampere we have 0.6 ampere. 0.6 into 1 is 0.6 volt. So that is the potential across R4, as it is having only 1 ohm resistor. And that voltage appear across the base and emitter of transistor Q1. Now, if that voltage is suppose less than 0.6, then transistor Q1 remain off, doesn't conduct the current. So Q1 will be remain off. In this case, the voltage regulator work in normal way. So there is no need of regulation. So voltage regulation work in normal way. Means we have the working will be normal. Now, if voltage suddenly increases, what happens? Now check carefully. When load current is between 600 and 700 milliampere, if load current flow, it is greater than suppose 600 milliampere, and if it is in between 600 to 700 milliampere, the voltage drop across R4 is between 0.6 and zero point 0.7 volt. And now in that case, the transistor Q1 is turned on, and if it is turned on, it will conduct the current. Now check carefully how, if this transistor will be become on, then current will be flow in this direction, or the base of Q2 is connected to collector, and collector will be reduces the base of the Q2. If base of Q2 will be reduces in this direction, if zero point 0.6 to zero point 0.7 volt appear across the emitter and the base of Q1, then what happens? The transistor Q1 conduct the current, and as it conduct the current, the base of Q2 will be reduces. As base of Q2 reduces, there is a reduction in the conductivity of transistor Q2. So series pass transistor Q2 limit the current or reduces the current. As current reduces, the output voltage also reduces and remain constant. So this is the working or the important part of working of this particular circuit. Okay. So once again we read number fifth point. When load current is in between 600 and 700 milliampere, the voltage drop across R4 is in between 0.6 to 0.7 volt, and if it is 0.6 to 0.7 volt, the Q1 is turned on and its collector current flow through R3 and causes decrease the base voltage of Q2. Base of voltage Q2 decreases and therefore output voltage decreases and prevent further increase in load current. So these are the important points. 5, 6 and 7 is important point of the description for this topic here. And when this will be happens, there is a process of regulation of voltage, output voltage remain constant here. Okay, so this is the working, and now we have a small derivation here. When load terminals are shorted, the voltage across R4 is, when we short the terminals, the voltage across RL is equal to the VBE, that is equal to ISL into R4. ISL is called short circuit load current, and that is equal to VB divided by R4. Okay, so this is short circuit current, and that will be flow through R4, and accordingly we have the VBE here. So where VBE drop across R4, and that drop is nothing but base emitter voltage of Q1, and R4 is current sensing resistor. By selecting the lower values of R4, we can increase the level of current limiting. So based on value of R4, if we lower the value of R4, we have the increase the level of current limiting. Suppose this will be decreases, this will be increases here. So this will be the two values on which the protection will be depend. One value is ISL and R4. So R4, suppose we lower decrease value of R4, then we can increase the level of current limiting here. Means ISC we can increase as VBE remain constant here. That is 0.6 volt. Okay. So this is general formula of the voltage across the base emitter of the Q1. Okay. Now we have some advantages and disadvantages. Now check carefully. Advantage: simple current limiting provides short circuit protection. So we provide the short circuit protection. And number second is series pass transistor and rectifier diodes are protected if load terminals are accidentally shorted. So the two components will be protected: transistor as well as series pass transistor as well as the rectifier diodes, if the terminals are accidentally shorted here. Again, so there are two functions: short circuit protection and also current limiting facility, that both will be as advantages compared to the transistorized regulator. But there are certain disadvantages. There is a relatively large power dissipation in the series pass transistor under short circuit condition. So when we short the supply, then maximum potential is appear across the transistor, that is series pass transistor, and because of that, when the potential across that is will be large, it has to dissipate maximum power, and heating will be produced, or there is a heating of that particular transistor, and that may damage the transistor. So when load terminals are shorted, nearly all input voltage appear, all the input voltage appear across the pass transistor, and when pass transistor will has appear all the voltage, it has to dissipate the power. Power dissipation is nearly equal to V in minus VB into ISC. So that much amount of power has to be dissipates, and so that there is one disadvantage, and for that we have the transistor should dissipate the heat to the environment, and for that purpose we require certain heat sink or certain metal connections, so that the heat will be easily dissipated. This is in case of when we short the input. Okay, so where VB is called the drop across current sensing resistor R4, and ISL short circuit load current. So this will be the calculation here, and accordingly the disadvantage is the power loss across, or power has to dissipate across the series pass transistor in case of the current limiting in series pass, a series regulator. Okay, so these are the two topics. So there in examination there may be one of the two, transistorized regulator or the series regulator. Check carefully, transistor is regulator, or we have the important question number second, current limiting in series regulator. Both questions are important. Okay, now we have the next topic, and that is of three terminal IC regulators, and that regulator will be in compact IC form, integrated circuit form, and that has only three terminals. So these are the new ICs having only three terminals. So what are the advantages we have given according to textbook? So advantages we over the older ICs, old IC or IC regulators having eight terminals or more than eight terminals. So check carefully. Number first point, early IC regulators had eight or more pins that had to be connected in various ways. So that is, we reduce the three terminal here in new IC here. Three terminal IC regulator can supply large load current from 100 milliampere to more than 3 ampere here. So IC has the range, large range of current here, load current. Now number next, these are available in metal or plastic packages, and they are inexpensive and easy to use. So they are available in metal or plastic packages and easy available, or there's inexpensive here, as it is plastic package and small construction, very small scale construction, small size construction, and they will be easily available as well as inexpensive compared to the 8 pin or more than 8 pin. Early IC regulator require many external components, but there our three terminal IC regulator require only a couple of bypass capacitors. So for three terminal IC only require bypass capacitors, either one or two, and in case of the old IC we require number of components, resistor, capacitor, and inductor also, in case of the old IC having 8 pin or more than 8 pins. Okay, so these are the advantages of 3 pin IC regulator over older one. Now we have a very simple diagram, functional diagram of the 3 pin IC regulator. So we have 3 pins. One terminal is V in, second is V out, and third terminal is common. And we have the block diagram in which we have one is called pass transistor, then second block is called thermal shutdown and current limiting, and one triangular portion that is called amplifier, negative, inverting and non-inverting terminal, and this connection is called V reference. Okay. So this is general block diagram